The debate lies in the anabolic ceiling of the current SARMs in development and the risk to reward profile in a supraphysiological context. What's up, guys? Derek, moreplatesmoredates.com. Today I wanted to do a quick overview of all of the side effects reported in the human trials conducted with SARMs. So there are, a lot of people want to speculate about what side effects SARMs have, what they do, what they don't do. Are they side effect free after all? I've done a video on this already that pretty much outlines it, but I want to do a more dedicated video on the specific side effects reported in the clinical data as per the studies, as opposed to just reiterating it in my own words. So I did an article following that video I posted on our SARM side effect free. In that article, I outlined every single side effect noted in the clinical data on all of the SARMs that have been tested on humans. So of those SARMs, we have Austrian, we have LGD4033, we have GSK 2881078, and we have PF 062-60414. So going through them in terms of side effect profile, these are the only SARMs that have been tested on humans. So looking at the side effect profile of anything else in rodent models, in cell studies, it's not overly, while it is indicative of sort of what you can expect in a practical application to some extent, at the end of the day, we want to see what happens when the stuff is tested on humans at, with tolerability and safety profiles. So getting into Austrian itself, which is probably the most prominent and well-known SARM, it is, categorized as a SARM because of its unique ability to activate the AR and transcribe tissue selective effects in tissues. I don't really need to describe how it works, I don't think, to you guys at this point. It is in phase 2 trials currently right now, and it has been missing the mark a lot on its efficacy measures. So I don't even think it's going to make it through, to be honest. But as far as, something with a significant amount of human data on it, it is one of the top SARMs. So getting into it, the first one that is notable is an increased hemoglobin and hematocrit. So small statistically significant increases in hemoglobin and hematocrit were observed with Austrian at 3 milligrams compared to placebo. So at 3 milligrams per day. Effect on lipids, as you would expect, reductions in serum lipids, namely HDL and LDL, occurred in a dose-dependent manner with Austrian. And another study showed only reductions of HDL, which is, otherwise more commonly known as good cholesterol to some people. We know for sure Austrian at least has a negative effect on HDL, which is, consistent with all the mechanism of other SARMs and anabolic steroids. Natural testosterone suppression, Austrian significantly lowered SHBG and serum testosterone levels in clinical trials in subjects with 1 milligram or more per day. While SHBG was always significantly impacted at notable dosages, suppression of LH and FSH wasn't consistently proven throughout Austrian's clinical trials. However, if you reference anecdotal logs and baseline pre-Austrian blood work compared to mid-Austrian blood work, with dosages several times higher than the 0.1, 0.3, 1, and 3 milligram dosages used in trials, it's pretty obvious that it has a dose-dependent suppression of testosterone levels. And the dosages in the studies just aren't high enough to yield this result. And I think, most of us will agree that SARMs are suppressive of HPTA in a dose-dependent manner. The extent to which this is significantly less than most steroids, though, to be, transparent about it. And Austrian is one of the least suppressive of all of them. The process of recovering to baseline healthy endocrine function would likely be hindered to a far greater extent in steroid recovery rather than Austrian. As far as liver toxicity, short-lived increases in ALT to above the upper limit of normal were observed in 8 subjects in one of Austrian's clinical trials. ALT observations in 7 of 8 subjects had resolved while continuing their daily dosage, and no subject had clinically significant abnormal levels of ALT or AST at the end of the study. One subject was discontinued due to an elevation in ALT 4.2 times the upper limit of normal. So the ALT in that subject returned to normal after stopping the Austrian. As you'd expect, obviously you stop the whatever the drug is, and then everything returns to normal. 25 milligrams will probably exhibit some level of liver enzyme elevation, and this is well documented. And when you actually look at guys' blood work when they use these hormones, or when they use these compounds, I should say. And this is contradictory to common bro science theories that assert there is zero chance of liver toxicity with SARMs at any dosage amount, or that, an increase in ALT must mean they have methylated prohormones or something like that. The reality is, in actual practical application at performance enhancing, what would be considered performance enhancing dosages in the community, increases in liver enzymes are commonly reported. Getting onto LGD-4033, so also known as ligandrol, also now known more formally as VK5211 under Viking Therapeutics. It's in phase 2 right now. So LGD appears to be the most potent SARM currently in clinical trials, and its data exhibits the most favorable selectivity for ratio of anabolic to androgenic activity. It's in phase 2 right now in the Viking pipeline, and while it was generally regarded as safe in human trials using dosages as high as 22 milligrams per day, it doesn't mean it had no negative effects. So this is what we're going to get into now. Effects on lipids, much like the Austrian, has a dose-dependent suppression of HDL and triglyceride levels. A negative effect on HDL is consistently noted with all steroids and SARMs, despite SARMs' ability to be selective about how they exert tissue selective anabolic effects. They evidently still have a effect on HDL, which is unfortunate, perhaps to a much lower extent than most steroids, but it's, still there and still notable. Testosterone suppression. So all SARMs have shown to suppress luteinizing hormone FSH through HPTA, decreasing test in a dose-dependent manner, and LGD suppressed SHBG and total test levels in clinical trials in a dose-dependent manner too. Serum-free testosterone and FSH levels were only suppressed in the subjects treated with 1 milligram of ligandrol. There was no suppression of LH in subjects treated with LGD during the 21-day clinical trial conducted on young men. However, these young men were only receiving either 0.1, 0.3, or 1 milligram for 3 weeks, which are pretty low dosages and also a short time frame. And based on the overwhelming supporting data on anabolic agents collected over the past half century, I think it's safe to say that LGD will show blatant reductions in all of these hormone markers in a dose-dependent manner as well. And the dosages in the human trials just weren't high enough to consistently yield this data. And at dosages higher than 1 milligram, I'm pretty damn sure serum-free testosterone levels would drop considerably as well as the dose is titrated up, and this seems to be consistent with anecdotal findings in anecdotal blood work. Liver toxicity. LGD didn't show any significant changes in AST or ALT in human trials, which is, very notable because at therapeutic dosages, at least in the clinical trials for Austrian, we saw the liver enzyme elevation. Obviously, the possibility is still there that dosage is higher than 1 milligram. There might be some sort of liver enzyme elevation, just not being reported. But as far as tolerability and safety profiles, LGD, and efficacy overall, just all comparing everything, LGD seems to be the top of the heap of SARMs currently in human trials. Getting onto GSK2881078. It's a SARM being investigated by GlaxoSmithKline for the treatment of musculoskeletal degenerative diseases. It was tested in a 2-part randomized double-blind placebo-controlled dose escalation phase 1 study. It was conducted on 108 participants, broken up into cohorts of young men and postmenopausal women. It was found to be well tolerated. Expectedly, causes a reduction in HDL. A few individuals noted constipation and nausea, which is probably just a coincidence in my opinion. One woman developed a rash, which was consistent with drug reactions. So perhaps some allergic response to a binder or a filler in the product, or who knows, could just be allergy to the literal SARM itself. Who really knows, to be honest. Probably not that notable though. 2 women experienced elevated ALT values 2 to 2.5 times the upper limit of normal during treatment, and 2 men experienced muscle soreness and elevated creatine kinase levels weeks into the follow-up period. So in general, pretty well tolerated, pretty low side effect profile, at least at these clinical therapeutic dosages. But you have to consider the fact that these aren't, performance enhancing dosages being used at 10 to 20 times the dose in the study. But anyways, we'll take that with a grain of salt. So getting on to PF 062-60414. It was involved in a phase 1 combination randomized double-blind placebo-controlled single and multiple dose escalation parallel group study in 72 healthy adult men of mixed ethnicity. It was found to be well tolerated. Decrease in HDL levels like you would expect, and increases in serum ALT levels were noted and consistent with other findings we have on other SARMs. And headaches, decreased appetite, dizziness, and upper respiratory infection were noted in some of the participants. A minority of them, which could be a coincidence, could be whatever. One man discontinued the drug due to fatigue, and another discontinued due to anxiety. So, fatigue could be, maybe HPTA suppression. Anxiety could just be, whatever. So pretty well tolerated as well, low side effect profile. Also notable, something that's not going to be reported in the clinical data is elevated estrogen or decreased estrogen. So this is a side effect that applies to all SARMs. SARMs don't aromatize into estrogen. However, they suppress natural testosterone levels, as you already know, which can create an unfavorable balance between androgens to estrogen in the body. And in addition, by occupying the AR with such a high binding affinity, you can knock off a significant amount of endogenous androgens that would otherwise have occupied those receptors. So the consequence of this could be a systemic elevation in estrogen levels in the body, which are commonly misinterpreted as pro-hormone laced SARMs, or it could be a systemic shift in the ratio of androgens to estrogen, and that ratio being thrown off can lead to a multitude of high estrogen side effects. And then on top of that, the long-term use of SARMs, suppressive SARMs, can lead to low estrogen side effects via HPTA suppression and eventual downregulation to the point where you have such a minimal amount of aromatization occurring that you don't have enough endogenous estrogen to fulfill basic physiological functions, and you start to experience low estrogen side effects. So those are the main side effects noted. And interpreting the data, SARMs versus anabolic steroids, there's a common misconception that all of the human trials on SARMs have been conducted using minuscule dosages and would lead to catastrophic outcomes if used at the same dosages of traditional anabolic steroids. And while I agree that the data on high dose SARMs is too limited right now, and there's barely any, to be honest, there were ascending dose studies to evaluate the tolerability of these compounds, and they're just often overlooked because they're really obscure and hard to find. So looking at the highest dosages used in clinical trials, first of all, we have it on Austrian, we have it on LGD, and a lot of people don't know about this. Austrian has been evaluated in 27 completed or ongoing clinical trials. About 1,500 subjects in total have been treated with Austrian in some capacity, with dosages ranging as low as 0.1 milligrams per day, all the way up to 100 milligrams per day. And Austrian was observed to be generally safe and well tolerated in all of these trials. So while it did not meet many of its efficacy measures in some of the data, its upper limit tolerability was assessed, and it was still well tolerated at 100 milligrams. So while this doesn't necessarily mean it's safe for long-term use, nor does it mean it's safe for short-term use at those dosages either, the evaluation of it being generally safe and well tolerated is notable, to say the least. And in addition to that, one notable phase 2 clinical trial that evaluated Austrian as a form of hormonal therapy for women with estrogen receptor positive and androgen receptor positive breast cancer was broken down into 2 dose cohorts. One was 9 milligrams per day and one was 18 milligrams per day. So this study is in women, and it's using 9 milligrams and 18 milligrams, which are, fairly high doses, and doses that are commonly replicated in the performance enhancing, context in the community in women too. So this is very notable. You have guys using almost this much for performance enhancement purposes. This phase 2 trial, pre-specified threshold for success, clinical benefit response was attained, meeting the trial's primary efficacy endpoint. So the trial enrolled the predefined numbers of evaluable patients in both dosage arms, with at least 44 patients in each of 2 cohorts receiving 9 milligrams or 18 milligrams of daily doses of Austrian, respectively. And this study in particular represented the first opportunity for us to gather clinical data representing what results would occur from what would be generally considered, high dosages of Austrian in a clinical setting. So in addition to that, the highest dose of LGD well tolerated in human trials. So the first phase 1 trial involving LGD was a randomized double-blind placebo-controlled trial conducted in 2009 on 48 healthy male volunteers. The volunteers were divided into 6 cohorts and received an escalating daily dosage of LGD ranging from 0.1 milligrams per day to 22 milligrams per day. And all doses of LGD 4033 tested in humans, even the 22 milligram per day dosage, were shown to be safe and well tolerated with predictable pharmacokinetics. So in a therapeutic context, when compared with steroidal androgens, SARMs do appear to be better tolerated with fewer incidences of severe adverse effects. And they're also orally bioavailable, which lowers the risk of accidental exposure, which is a limitation of topical testosterone as well. And obviously, when it comes to adoption of use, oral therapies are going to be favored over injections as well. And the most consistent hindrance of health markers shared between most SARMs are decreases in HDL and transient increases in ALT. But this is in a therapeutic context, is what you have to take into consideration. So this is not, in a super physiological muscle building context for bodybuilding purposes. So when it comes to using massive dosages of SARMs for bodybuilding purposes, are SARMs still safer than steroids? From an androgenicity context, I think the answer is undoubtedly yes. But for most of them, at least, not for some of them, some things like S23 there's probably more tissue selective steroids out there, to be honest, in some places, in certain compounds. But the human tested SARMs that have shown the most promising efficacy, sort of what I'm referring to right now. So androgenicity context, probably yes, probably better than, steroids. When it comes to hepatotoxicity, suppressed lipids, and HPTA, is the risk to reward that much different? That kind of remains to be seen. Frankly, I believe certain SARMs are probably going to be more favorable on health markers at all dosages, milligram for milligram, compared to most steroids. But the issue is their muscle building potential is lower than that of many anabolic steroids. So, and this is significantly lower when it comes to certain SARMs. So some are formidable to many traditionally used steroids, and some are just not. And, some are more effective than others. But the question arises, if you're going to smash your lipids and shut down your natural testosterone levels anyways with mega doses of SARMs, would it not be worth it to just take the plunge into actual AAS instead of muscle growth as the goal, and you want something that has more human data on it? So that's where the real debate is, in my opinion. And the debate is not whether or not SARMs work. We already know how they work, the mechanism of action. We know they do work to an extent, to a fairly significant extent in the therapeutic context. Replace steroids in all contexts, not just, in a clinical setting, but also in a bodybuilding context, in my opinion. But the debate lies in the anabolic ceiling of the current SARMs in development and the risk to reward profile in a super physiological context. So I think SARMs are the future of performance enhancement, as well as the prevention of musculoskeletal degenerative disease, and they will continue to improve as time goes on. More efficacious compounds are synthesized, and they're going to slowly phase out traditional anabolic steroids. But this doesn't mean the current ones are side effect free, and they're certainly not all equal to one another at all in terms of efficacy to risk to reward kind of thing. So like S23, for example, I commonly refer to this. This is something that's being looked at as a potential treatment for androgen deficiency in postmenopausal women. So just because something's more tissue selective than testosterone, if it's being used to increase libido in androgen deficient women in menopause, and it's also being used as a contraceptive for men that would replace the androgen dependent functions typically mediated by testosterone and DHT, like, is that something that sounds very tissue selective and not androgenic to you? Like, it's almost like a more tissue selective version of Proviron if you actually look at the profile of what it's being developed for. So just because something's more tissue selective than testosterone, it doesn't mean it's like a, efficacious SARM, in my opinion. Should something be considered, a SARM just because it's more tissue selective than testosterone? Obviously the data has its own definitions of how stuff's referred to, but ultimately it's going to be up to you to interpret this stuff correctly for figuring out what's actually efficacious, not just, this is a SARM on paper, so it must be, have no androgenic activity and no side effects and blah, blah, blah. It's not how it works. There's going to be ones that are far better than others for their purposes intended, and some that are just pretty crappy. So it's going to be kind of on you to sift through the data and interpret this. And It can be confusing, but it's definitely good to learn how to dig into this stuff yourself and interpret it. And there isn't enough data to make any conclusive statements on their long-term safety or overall efficacy right now. But from what we do know, we can see that their development is definitely on the right track and is paving the way for superior anabolic agents. And the current SARMs in human development, some of them are pretty promising, in my opinion. Like LGD, like some of the other stuff being developed right now. And yeah, I guess we'll see how it goes. So that's basically the video for today. So thank you guys for watching. Please like, subscribe, check out my blog, moreplatesmoredates.com. Check me out on Instagram at moreplates_moredates. Facebook, Twitter, Snapchat, etc. Check out the podcast, link in the video description below for audio format of my videos and articles. Subscribe to the newsletter on moreplatesmoredates.com if you want to get an email every time I publish an article. The articles always have links to all of the clinical studies, which I never include in the video descriptions of the videos. So there's some incentive for you to actually subscribe to the newsletter, because then you'll get to see exactly where all this data derives from in an organized way. So highly recommend you do that. Thank you guys for watching. Talk to you soon.